let's get rolling. We'll end a little early today so we can have time to do that quiz. And honestly, hopefully by the end of this class, the part of that quiz will be answered several times over and over. Yeah. So let's see, who's not showing today? So folks not showing today, is it because there's a quiz? No. I know at least one isn't. One person is out sick, so we appreciate them not coming. Let's take a minute. Let's take a minute to get settled, because I need to get settled. Let's just sit up, close our eyes. And settle in, whatever that means to you. Where does your mind go when you just let it go? Let's just watch for a few minutes. What you probably find is that it goes about 1,000 different places. Just gently bring your attention to watching what your breath does. You might be noticing that at your nostrils or your belly. There's no wrong answers. Toes a wiggle, fingers a wiggle. Come on back. Beautiful. So, friends, is there anything I can answer for you? Is there anything on your minds or concerns that you have that we should talk about? We're good? We're good? Make eye contact with everyone. Yeah. Okay, all right. Good. Ooh. Sorry. All right, let's do a warm up. So, karma-free warm up. How is a translation the same as two reflections? So I want you to just think about this. Can you reconstruct roughly how that worked? How was it that a translation by B was two reflections? How did that work? And then maybe if you can just quickly think about how rotation by theta works. I just want to talk about that because it was the last thing we talked about, and see how much of that you might remember. And we won't spend long. It's, like I said, no grade assigned. Just practicing summoning that knowledge. this drawing kind of coming into your mind for the translation one? So if we want to translate by B units, remember in the complex plane, that's also a direction when I have a complex number. So I'm going to let B be the translation factor, and I'm going to cut it in half, and I'm going to make lines that are perpendicular to that direction. And then we're just going to flip over the first one and then over the second one. So we first flip over this line, and then we flip again over this line. And that ended up translating us by B. So it was just two parallel flips in a row, each by half the distance. And in the direction of the actual translation. And I'm pretty sure I saw Tara drawing this picture here. For the rotation, we first do a reflection over, so we flip over the horizontal axis. So if this was Z, I first flip over the horizontal, and then I flip that result, so that's Z conjugate, over a line that is through the origin with half the angle that I want. So flip over this, and then flip over this, and that gets you an effective theta. Is that all vaguely familiar? Cool. You can always look it up. It's not what the quiz is on today, so no rush. What is inversion? So this was one of the things I asked you to study for today. That's what the quiz is on. Let's just see what folks have to say about it. I want to talk about the basics today. Can somebody maybe just give us like a 10,000 foot view of inversion? Inversion with respect to what? What are we inverting around? Circle, that's cool. So if we know that, then we know something about what's going on here. Let's just start with the unit circle. Start with nice and chill. We got a point Z. What does it mean to invert that point? I care to.
You're reflecting that point across the circle?
Yeah, I mean, in most basic sense, it's reflecting this across a circle, which is a much weirder thing than reflecting across a line. But in some ways, they're actually the same thing. One of the things that's going to become truer and truer for us is that lines and circles are the same things. It's going to turn out that a line is just a circle that passes through infinity. So this idea, once you see that, then this inversion here is going to make a lot more sense when compared to inversion over here. And that thing that I just said about a line passing through infinity will make way more sense as we move forward. But yeah, I'm just going to flip this over this circle. So to do that, I'm going to draw a line between the origin and my point that I want to invert, and I'm going to say, okay, I've got this point out here that represents the inversion. The relationship between these 2 points, the modulus of Z star times the modulus of Z is equal to 1, which happens to be the radius of that circle. Does this sound familiar? Yeah? So if I were to say to you, what does it mean to do inversion in the unit circle? I mean, you could draw that on the table. I'm probably going to ask you, like a half hour or so again anyway. But this is what I'm talking about for just the basics of inversion. What is the formula? Does anybody remember what the actual formula is here? Lou might, because we were talking about it. Yeah.
For the unit circle?
For the unit circle, yeah.
It's 1 over Z conjugate.
Yeah, 1 over Z conjugate. So it's a lot like normal. We think of inversion as 1 over, but there's an extra twist here. Let's actually understand why that's so. Let's actually do a computation. Let's pick a Z that's inside the unit circle. So, example. Let's say Z is equal to 1 no, excuse me, 3/5 plus 4/5 I. Very carefully crafted number there. So if we want to find the inversion, and that's, yeah, that doesn't quite look like it. This is probably more like the one. Well, fuck it. Oops. Whatever. I'm not going to try to draw them up there until I get them all worked out. So Z star is 1 over the conjugate of that. And we don't leave numbers like that. So we multiply by its conjugate. And I think that I actually picked a bad one. Wait, is that on the unit circle? I think the thing I picked is on the unit circle.
Yeah.
That's okay though, we'll see what happens, yeah. So I think this point that I picked actually lands on the unit circle. What should its inversion be? What's the inversion? If I take something on the unit circle,
The same point.
should be the same point, right? So check it out. If the modulus of Z is 1, then the modulus of Z star should also be 1. So I should get back the same number, and in fact, that's actually what I am going to get here. Because the top is the original, and this bottom is 9/25 plus 16/25, which is 25/25 1. So we get back exactly what we started with. Let's pick something a little bit more interesting. What about, ooh, let's try a good one. How about 1/100th I? What is the inversion of 1/100th I? Let's crank that out together. You can probably maybe do it in your head. So let's use some notation. If that's C, the book uses inversion around C of 1/100th I. You multiply top and bottom by what to simplify that? How are we going to simplify that? Just a conjugate of this thing, right? So positive 100th I. And then the top is 1/100th I, and the bottom becomes what? What is the bottom?
Negative 1/100 to the 10,000 squared.
They're squared, yep, definitely. And since I have negative I times positive I, that becomes a positive 1, right? Because the I squared is negative 1. Yep, all good. Just good to think through this stuff together. And notice that this turns into, if you simplify it all, 100I. So I can't even put it on the board. But it's exemplifying a certain property of inversion, that the closer I get to the center of the circle, the further away I'm cast by the inversion. So the 100I isn't even in this room, right? It's way up here. The closer I am to the edge of the circle, the less I move. If I'm actually on the edge of the circle, on the circumference of it, I don't move at all. I stay right where I'm at. So one thing you can think of is it's like, imagine a metal hoop on the plane, and you're taking the center and tearing a hole and flipping the entire plane inside out. So the stuff that's at 0 goes way out to the edge. Just imagine pulling that open, little metal hoop here, and all the stuff that was outside becomes the inside. So just in the same way that the inversion of this number is this number, the inversion of this number is that number. So there's a nice reciprocal relationship between inverts. All right, so let's come up with that formula. because it's good to see this once. How do you get this formula from just that property? Okay, so to get the formula for Z star, notice that Z and Z star are on the same line. This is a super important property of inversion, that the thing you're inverting and what it goes to are on a line through the center of the circle. So I'm gonna come down, got my picture, here's my unit circle, good old buddy, unit circle, got Z conjugate somewhere out here, don't know where exactly. But that is in line with Z. So Z star is just some multiple of Z. Does that make sense? That it's got the same direction, it's just got a different magnitude. Stretching, it's a stretching of that original point. So once we have this, let's go back to our equation over there. Let's see, is this what I want to do? Yeah. And since Z star's modulus times Z's modulus equals 1, what that's going to give us is KZ. So we have KZ modulus times Z modulus equals 1. This K is, what can I say about this K? It's going to be a real number. It's a positive number because I'm scaling out. So K is a positive real number. If K was a negative number, it would take me in the opposite direction, and Z star would be over here. That's not what we have here. That's not how inversion works. So check this out. I can just pull that K out, and I'm left with this. Easy. Wow, it's pretty overwhelming, but get you some cushions back there to handle the math fall.
Do you mind if I close that pointer?
I can take care of that for you. What can I do for you? This is creating some kind of glare. Is that what you're trying to avoid? We can try to do some light stuff too, but yeah, let's close this window up. Definitely don't want you to get a concussion or anything, because how's that, Nathan? Little better?
Yeah, that's better.
Is that, are you sure?
Yeah.
Okay. All right, good. So I'm gonna plug this now into that formula. So Z star is just 1 over modulus of Z squared times Z. And then I'm gonna use a special formula for this. It was on your first homework, you were asked to show that this modulus squared is this quantity. And the Z's cancel, and we're left with good old 1 over Z conjugate. Not a thing you would guess, but not too bad to derive. All right, let's move on to inversion in an arbitrary place. Once we understand this, we can generalize it. So now, let's invert over or about or with respect to, there's lots of different ways to say this, and I'll probably say all of them, over a circle of radius r at center Z naught. Drawing out the picture, it's just floating out in space somewhere in the plane. There's our center, there's our radius, r. Here's the point I want to invert, and on a line through the center, and that point is somewhere out here is the inversion. So we can use all the same reasoning we did before, but the key thing is the geometric relationship is that the distance from original to the center times the distance from our inverted image to the center is equal to the radius squared. So in other words, the z star is defined to be the number that makes this true. And you can see here, notice that if this point z were actually on the circle, that the distance from z to z naught would be r. So you get r times r equals r squared. If you're on the circle, this just checks out, just naturally. This is not terribly easy to work with, but it's a fact we want to have in mind for today, of all days, but moving forward. But we have a lovely formula that's equivalent to this one here. And you can derive it in the same way. Let's see if I can actually derive it. Z minus C naught conjugate. Is that? Yeah, okay, cool. Wow, I did it. Yay. All right, cool. I passed the quiz. Congrats to me. Cool, so we've got that formula. I don't know if I want to say a whole lot more about it, but let's actually compute one just together. Everything cool? Okay, awesome. I did hear something though, right? Okay. Don't do it, don't invert things. All right, I'm just gonna let Grace go. So let's say that our circle, ooh, it looks like I did all sorts of fun stuff here. But let's say my circle C has a center at 1 plus I, and it has a radius of 2. So our circle C has a center, I'll just kind of write it out this way, a center of 1 plus I and a radius of 2. And we would like to invert 0 in that. So find the inversion of 0 with respect to this circle. You can draw a picture too if you end up getting bored, seeing what's up. It turns out to be cool, I think anyway. I'll start drawing a nice picture. Yes, yes, good stuff. That means I did it right. That's great. Conjugate. There we go. Okay. Almost messed that up. So that is 1 plus I plus 4 over negative 1 plus I times negative 1 minus I. So there's doing the division there. Straightening out the denominator. So negative 4 minus 4I over 2. Yep, that's looking good. I don't know what that is. There we go. So 1 plus I minus 2 minus 2I, negative 1 minus I. So inverts to right there. Check that out. Make sure this all makes sense. I know Lou got the same thing I did. It's making me feel pretty good about it. Literally the third time then that this problem's been worked, because I did it before and I got the same thing. Let me know if there's any troubles with that, or if that feels okay. You look concerned, Lou.
Huh? Oh, no, I was just thinking
Oh,
about something.
oh, you're thinking about something else. Thinking about something actually concerning. Okay, good, fair enough. Does this sound cool? Yeah. Cool. Very good. Very, very good. What is a climb? It's quiz practice. Oh wait, should I stop here because folks are still looking at that? Is there anything that needs explanation there? Let me stop. Do you want me to go through that, Kitra?
No, I just have to like do the.
Okay, sorry, I'll shut up and let you do it.
No, you're good.
What are you thinking about, Kitra? What are you thinking about?
I'm just.
I'm trying to think. What's a climb? Ella, are you good on that?
Yeah.
Okay, awesome. Okay, cool. Pretend the quiz is now. What's a climb? You've helped us today. Nathan, what's a climb, my friend?
Oh, you can leave in a circle or line.
Hey, right on. Circle or a line, right? It's a nice word that combines circles and lines. It also is said, like one of the great geometers of our time, Klein. You've seen Klein bottles. Dr. Seibert has a Klein bottle in his office. Anybody ever seen this? Yeah. Yeah.
What are they?
Oh, a Klein bottle is a bottle that has no inside or outside. Yeah. It also looks a lot like a bong, which is yeah. Ask Dr. Seibert if you can see his Klein bottle, or look it up. Yeah, look up Klein bottle. So, what is the equation of a climb? Let's see. So Nathan got off pretty easy. Grace, do you want to help me with that? Oh, sorry. No. Okay. No, I see. You got stuff going on. Ella, can you help me with Klein equation?
I'm gonna try to do it.
Yes. Excellent. I love this.
CZ Z conjugate plus AZ conjugate plus D equals 0.
Hell yes. Good work. Thank you. We can all do this, or should be able to pretty shortly. Yeah. So it's just the line equation that we've already memorized with this extra quadratic term out in front. If you actually simplify this front term, if you have z equals x plus iy, then that's just c times x squared plus y squared plus some line stuff. But here's where your x squareds and y squareds come in for the circle. The circle equation that we're used to, which is you've got a circle centered at x naught, and actually, yeah, that's the circle equations that we're used to. So I have a circle at x naught, y naught, radius r. What is if this is a circle, when is this a circle? When? How about this? Here's an easier question. When is this a line? Yeah, solid. Thank you, Ella. When c equals 0. What is Grace? Oh, Grace, awesome. Thanks. Well done, Grace. Thank you, my friend. Can you help me with the rest? Because this is where it gets a little. Yeah. So when is it a circle?
When C does not equal 0.
Close. Pretty close, but there's like a little bit of a weird ass tweak.
The modulus of a squared is greater than cb. I think.
think that that's right, yeah. Yeah, so when this holds true, which certainly means that certainly C has to not be 0, so you're absolutely right. So that is definitely part of it. C should not be 0 when it's a circle. But more importantly, we need this to actually have real solutions for it. Does anybody remember where the center is?
Negative R, like capital R-E with the alpha in the middle.
With what's in here? Sorry.
A
Yep.
over C.
Yeah, beautiful.
And then the next part's, was it an I or an L?
It's an I.
Okay,
Yeah, it's the imaginary
okay,
part.
That's what, and then alpha over C.
You got it. Nice. So the real part of that alpha negated here over C, and then, yep, imaginary part. Nice. Cute. Cool. So given this equation, which is completely mysterious, we could actually do something with it in certain circumstances and plot it. How many points do I need to know what's going on here? So I tell you, I've got, well, let's start. Let's play like hangman with points. So how many points? Garbage. Utter garbage. Come on. Come on, baby. That's pretty good. How many points to determine a climb? So here's 1 point. Got a Z naught. That doesn't determine anything, right? We could literally have a billion different things coming through this. Lines, circles, other weird shapes. Does that determine a cline? If I just gave you those 2 points and said find the cline that passes through these two, does it give me a unique answer? No, because there's lots of different lines. There's only one line that goes through here, but we could have many circles that come through here, right? Imagine that being a really big circle that I just did there. So we need 3 points. 3 points. So the first two are going to set up a potential line. It's where the third one falls that determines everything. So if the third point is collinear with those first two, then we have a line. As soon as this one is off of the line connecting the first two, we have a circle. And let's see how we get a circle. I want to do a day where we just bring in compasses and rulers and we do some building stuff on paper. We're gonna do that day. If I gave you 3 points on a piece of paper and you wanted to construct the circle that contains these 3 points, does anybody know that, how do I construct that? Somebody walk me through.
Wouldn't you just draw a triangle?
So we got a little triangle. Where's the center of the circle?
Would it be half of that? Well, no.
Not necessarily, right? Because if the points were almost in a line, like that, then I'd have a big ass circle, right? Do you remember how this works, Lou? What was it?
You take the bisectors between like Z1 and Z2, and then Z0 and Z2, and when they intersect, that's the center of the circle.
Yeah, and so you pick any 2 pairs of line segments here, bisect them. And we're gonna have to, I wanna do all this stuff in class, so at least people who are gonna teach like grade school know how to remember how to do line bisectors and stuff like that. Let's say I wanted to construct the bisector, the perpendicular bisector of this. Well, I would get a compass. Let me show you how this works. I would get a compass and I would hold it at one of the points and I would make a little mark like that. and then make a little mark below at the same distance. And then I would take that compass and move it to the other point, make that mark, and then make this little mark down here, and connect those with a ruler. And that produces the perpendicular bisector of this line. So we're gonna do that for this one, we're gonna do that for this one. And where they intersect is the center of our circle. And the radius of our circle is the distance from that point to any of these others. So after you build that, then you set your compass to that distance and spin. You've got yourself a really beautiful circle. So that's how you would build it if you had to. What's another way I could get the equation? So that doesn't give me, it still doesn't give me the damn equation. How do I get that equation with 3 points? So I've got 3 points, let me give you 3. Let's say I had the points. Where's my old points? I've got some cool one that I worked out here. I'm not sure where it went. This is weird. I remember doing a problem with myself. Oh, here we go. So find the equation of the climb through, and I gave you 0, 1 plus I, and 2. How would we do that? We don't have a ruler or compass, let's say. How could we build this thing? Is this going to be a line or is it going to be a circle? First off, let's just kind of. What do you think?
Circle.
Circle, right? Because there's 0, there's 2, there's 1 plus I. Those are not collinear, so definitely a circle. Seems like the center will be down here somewhere. How can I find the equation that I need?
Well, my first assumption is just plug in values.
Hey, that sounds like some math stuff. I like it. Yeah, plug those numbers in there and see what happens, right? There's 3 unknowns. C, alpha, even though it has 2 parts, and D. So, oh, and also what do we have to, let's just make a note here that C and D are real numbers, right? Those are all real numbers. So I just literally plug those in like you said, Kendra. You got it, right? So plug into general form and get 3 equations in C, alpha, and D, and solve for those 3 things. Then this one, let's do it because it's just kind of pretty to see this all come through. At least I was amusing myself with it at home. So maybe you'll be mildly amused. If Z equals 0, I've got D equals 0. Well, that's all right. I'll take that. 2 things left to find. If, let's do the second lowest hanging fruit, Z equals 2. So that's going to be 4C plus 2 alpha plus the conjugate of 2 is just 2 alpha conjugate plus D, which is 0, equals 0, huzzah. That's not bad. And then we'll plug in this 1 plus I, and we're gonna get the modulus of 1 plus I is 2. That's, modulus squared, sorry. The modulus of this is square root of 2. Modulus squared is 2, so I have 2C plus 1 plus I alpha plus 1 minus I, the conjugate, alpha conjugate equals 0. And from here, it kind of gets painful a little bit. So to solve for this, you'd want to maybe multiply this one by 2 and then subtract down to just get alpha and alpha conjugate equations. Or try to clear out either the alpha or the alpha conjugate. Let me give you the solution because I already worked this through. Did I? No, I didn't. Son of a gun. Not on this page. Well, do I regret going here? Yeah, we got this. We can do this. I am a little scared. Just because I think it's gonna be messy. So let's make this top one look a little closer to the bottom. I've got 2c plus alpha conjugate equals 0. That looks a little better, all right. And then these bottom ones, well, I feel like, I don't know, let's just put this here and see what happens. Was there an idea over there? No? Okay. So we've got 2c plus 1 plus, that alpha looks weird ass. 1 plus I alpha plus 1 minus I alpha conjugate equals 0, and then subtract down. So we're gonna get, oh, this isn't too bad, then this might be revealing. So 1 alpha minus 1 plus I alpha is going to be minus I alpha. And then alpha conjugate minus this critter here is plus I alpha conjugate equals 0. I could divide both sides by I, and so I've got minus I plus minus alpha plus alpha conjugate equals 0. And then, oh, look at this. This will be great because this is, if we say alpha equals A plus BI, I was trying to avoid going here, but I can't. Then alpha conjugate is A minus BI. And so this formula over here is going to become minus A plus BI plus A minus BI equals 0. Notice how the A's cancel. And I get that the B must be 0. So our alpha definitely has to be just a pure real number. And then, can any of this help us? I guess we come up to here. So alpha is a pure real number. Pure real. And then that makes this top part real easy because we know that 2c, wait, we don't have c yet, do we? No.
Quick question.
Yeah. Thanks. Sounds good.
For the part where we go from like the negative I alpha plus I alpha conjugate,
This thing?
we're just allowed to divide by I?
Yeah, because it's
Zero?
not 0.
Okay.
So it's totally cool. It's funny when I was thinking that, I was like, everybody's cool with this, right? I'm glad you asked.
Yeah.
Yeah, you can divide by I. Totally kosher. Totally good. Okay, so we can actually redo these two equations then. Now that we know A looks like that, so I've got 2c plus A plus A, because the conjugate part is, the conjugate's the same because the real part's dead. So we get this, and then down here we're gonna get 2c plus 1 minus IA plus 1 plus IA, 1 minus IA, that equals 0. Let's do a little simplifying on this bottom equation. That's actually gonna turn into 2c plus A, so plus 2A. These two equations are the same, aren't they? Because here I've got plus IA minus IA, those cancel, and then I've got plus A, so I get the same equation again. So I've got both these equations that are the same. Where's my extra information coming from? I bet I have to try to get rid of something else over there.
Do you not have enough equations because we've got 4 unknowns?
But the two of them are interwoven together. Like, we should get a unique answer out of this. That's a great question, but that because that alpha and alpha conjugate are so closely related, they kind of act like one.
I was talking about the A and B and
Oh.
alpha.
The A and the B where, I'm sorry?
Because alpha's A plus BI.
Yes.
Yeah.
Yeah, but the B had to be 0.
Yeah.
So where's my extra info coming from? Or where could it come from? Well, I don't know exactly. So like when I built this thing, I was thinking the center of the circle would be at 1, right here, which might be right. Part of me just wants to say, I'll just do this at home or do it while you're taking the quiz or something like that. And maybe that's actually the right answer. Because I need to think about it a little bit more. And I don't want to just spend time doing super nasty algebra that I think, no, we gotta do this. We've gotta do this. Okay, hold on. Okay, one more try. So that top equation is, no, shoot. I don't know. It's weird because I actually came up with an equation at home and I don't know what the hell I did that was different than what I'm doing now. I don't know. I gotta work on it. I'm just gonna work on it while you're all. I have to pee super bad, so like, I'm feeling this desperation. Can I just go? I'll just go do that. Let's see if you can figure this out before I get back. Thanks.
I missed like the first like 30 seconds of the explanation of what we were even doing, and so now I'm like so lost.
We have those 3 points, and we're trying to, which is supposed to form a circle, and we're trying to make it into that equation.
Is it because we don't know what each point is that we,
So we do know the points. We know 0, 1 plus pi, and 2. It's
but
just
we don't know where the
have-
center or the radius or.
Yeah, so we don't have the variables C, alpha, and B, so that's why we're plugging it in.
Hmm.
Yeah, so we just plugged in the points, got those equations, and trying to figure it out from there.
Okay, I got it. It's like sometimes you just have to change your scenery. This is okay. we're all good here. So A and B, A and C, D is 0, right? So we've got this equation that looks like this. And we know that A and alpha are the same because alpha is just a real number named Z. And then we came up with this relationship right down here that says 2C plus 2 alpha is 0. In other words, C is equal to negative alpha. That has to be the case. If I divide through here by C. So in other words, like let me try this. So if I set alpha A equal to 1, then C is equal to -1. Notice that if A was 2, C equals -2 doesn't change this equation at all. It just changes it by a multiple. So for example, I'm just gonna let A equal 1, C equal -1, and then this equation looks like this. And the C was -1, right? Like this. If I set A to 2, then C is -2, but you can just divide through by that leading coefficient. And notice that A over C is just -1 anyway, no matter what. So what we get is a lot of different equations that are the same equation. You get this, or maybe you've got minus 10 ZZ conjugate plus 10 plus 10, 10Z plus 10Z bar. Same equation. So we're actually just getting no new information, everything's cool. We're just getting multiples of the old equation. If D had not been 0, then this would not be as weird as it is. So this equation right here, that works for us. So does this one. So does any multiple of it. Good old go to the bathroom. All right. Thanks, bathroom break. Well, friends, that's all I wanted to say today about this. I would love for you to please keep reading through this section. We're gonna keep moving forward with it. I don't have a homework assignment for you yet because I want to talk some more first. Can we just do our quiz and get it done with? Yeah, if you need to take any last glances at whatever you got to glance at, take a moment. Just let me know when you're ready.